Guys, so this will be a walkthrough on assignment 1, which is on a composite selection. So first part will be on the background on a typical male galley trolley. So just these are some context on what galley trolley is, and also what stresses it faces when during operation. Okay, so first part will be selection of materials. So these are the 6 properties that we consider more important in terms of looking into a galley mill trolley. So as mentioned in the video guide, you have to find this material, which is aluminium 6061T6, and look into the average values property using the Granta application. So these are the constraints that you need to set to be able to filter down and find your composites to be used for the galley trolley. So first one will be we must make sure that we will be selecting composites and not like metals and all that. Okay, then second will be make sure that the properties are equal or even better than the benchmark material, which is aluminium 6061T6. Must be resistant to water. We set this as the material source must be cheaper than 100 Sing dollars per kg, and also flammability regulations, so must abide by it. So as mentioned just now, we do not want any other material than composites. So some of the wrong form composite form you can see here. This will be when you press into the materials itself. You can see that the form is fiber, which is not what we want, or maybe it can be metal, which we also do not want. Recommended correct composite form we see here will be the material family that shows here will be composite. These are maybe the different types of composites. This one, for instance, this one is polymer matrix. So from there you can be able to select your composite materials based on the filtered composites. So we will need 3 composites here, and this one will be a benchmark material which will be used for ranking. So we'll be choosing from 3 of the composites the best one from 3 of them. So to be able to choose or rank them, we must make sure that the properties are of the similar or same scale. This is, for instance, we know that price and density, their values are different, so we need to make sure that they are standardized. So we will be able to standardize them based on these 2 equations. These 2 equations are similar, however, equation 1 is used when the property is where lower is superior. So for instance, density, we want a lower density material in comparison with a higher density. So we'll be looking into using this equation. For the second equation will be the opposite, where we want the property value of higher value to be superior. So for instance will be your tensile strength or fatigue strength, where we want a higher tensile strength in comparison with a lower one. So with that, we can then look into weighing of the various materials. So for this portion wise, we have constructed a proper weightage table looking into different properties weightage. So this one you do not have to do, which will be done by us. You can see here 1 and 0. 1 it shows that is more superior. 0 is not more important. So for instance, you see here property 1. For us, we consider property 1 more important than property 2, 3, 4, 5, 6. So all will be 1, 1, 1, 1, 1. And will result in the property having a higher weightage. So as mentioned just now, 0 is not more important. So property 2, we know that it's not more important than property 1, which is density. So these are all the weightage that we are given to each of the properties. With that, we can then we can derive the performance index. So this will allow us to see each material's total performance. Okay, so this will be a table that will be constructed. So these are the values that we'll be able to find using Granta Edu software. And with that, we can look into the property index. And then we can rank each of the materials. After that, there's a small portion on commenting on the composite. So you can talk about why this property rank higher than the other. And also what are the results that you can derive from it. After that, we'll be looking into the loading index. So as we know, there are 3 types of loading faced by the galley trolley, which are as such: tension, compression, and loading. So we save some time for you. We derive the equations, and these are the 3 equations we'll be looking into to maximize the loading. So with these 3 equations, you just have to input in the values of each of the properties, for instance yield strength and also density. So one key symbol that you may not have seen before will be this, which is a shape factor. So with these equations, you can be able to find the values and also then add up and rank it amongst each other. So from there, you can be able to look into both its rankings and find the average rank. This will then allow you to find the final selected composite material. So one thing to note here, is that if there's an instance where 2 composites have the same average ranking, you'll then be using the chart index selection stage as mentioned in the Granta guide, selection guide, where you can use the chart index selections to look into various properties. For instance, you can maybe look into why you choose the final selected composite based on maybe it has a lower density and higher strength in compared to another same average rank material. So from there, you can be able to support your answer on why you choose this final selected composite. So after finding the selected composite, you then have to export the composite material into OneDrive for your FEA analysis. So for this question wise, you can be able to find the answer in the Granta Edu application. For this question looking into fabrication of your final selected materials, this can probably be found online, where you just have to search for the material through Google or something. That will be all for assignment 1 on composite selection. Thank you.